Let us move on to next question, question 10. Very well. Question 10 says, some of the following. Here you have dy over dx. And on the right-hand side, we have 2y plus 3 divided by 4x plus 5 to the second power. So is it separable? Okay, let's see what we can do. First of all, from algebra, we can separate the exponent for the numerator for the denominator. Again, doing pure algebra. You get dy over dx equals to 2y plus 3 to the second power divided by 4x plus 5 to the second power. Well, I have an expression in y, I have an expression in x, and dy dx are on the other side. So let's multiply everything by dx. And what we get dy equals to 2y plus 3 squared dx divided by 4x plus 5 to the second power. I have dx divided by 4x plus 5 to the second power, so I'm good with this part, but I see an expression in y on the right-hand side, which needs to be on the left-hand side. So divide by 2y plus 3 to the second power. So what do we get? We get dy over 2y plus 3 to the second equals to dx over 4x plus 5 to the second. Is it separable? Yes, as you can see, it is separable. What's the method of separable differential equations? Well, we need to take the integrals of both sides going back to elementary calculus and use the methods that we learned before. Take the integral of both sides. Very well. Now, doing calculus. Here we have the integral of dy over 2y plus 3 to the second equals to the integral of dx over 4x plus 5 to the second. So you already know how to solve these integrals by using substitution. Substitution. Well, for the first one, you can say that, hey, my u is equal to 2y plus 3. So du is 2 dy. And for this guy here, you can say that, hey, my v is equal to 4x plus 5. So my dv is 4 dx. So your first integral becomes the integral of, very well, here you have a half du divided by u squared equals to, here you get 1/4 integral of dv divided by v squared. Again, recall that when you have the integral of dx divided by x squared, here it's equivalent to write it as x to -2 dx, which is equal to negative x to -2 plus 1, which is -1 divided by x. So your left-hand side becomes negative 1 over 2u equals to negative 1 over 4v plus the constant of integration. Remember that your u was 2y plus 3, your v was 4x plus y, so let us replace this. You get negative 1 divided by 2 times 2y plus 3 equals to negative 1 over 4v, which is 4x plus 5 plus the constant of integration. Remember that here you could simplify the whole thing. You could say that, hey, I can cancel out a half and a half here. So you could just write this as 2v instead of adding more complexity here. Very well. Now the question is, can I simplify this more? Okay, very good. Can I just isolate y on one side and write it in terms of x? I have to do a little bit of just algebra. So by doing algebra, we can write it in the terms that y is equal to an expression in x. We can isolate y. Or you can just leave it as it is.